Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. This is problem number 14 from multiple choice section from the October 2018 exam LTAM. Joe, age 65, and his wife Lucy, age 55, purchased a special 10-year deferred annuity policy with the following premium and benefit terms. Level annual premiums are payable for at most 10 years while both Joe and Lucy are alive. There are no annuity payments during the first 10 years. After 10 years, at the start of each year, the annuity pays $100,000 if both Joe and Lucy are alive at the payment date, $55,000 if only one of them is alive at the payment date. You are given the following assumptions. Joe and Lucy have independent future lifetimes. Mortality follows the standard ultimate life table. Interest rate is 5%. Calculate the annual net premium. And here's the solution. Let us write P for the annual net premium sum. Then we use the equivalence principle to write P A:55:65 angle 10, and that refers to at most 10 years. That's kind of a strange expression, but the premiums are payable during the first 10 years if they're both alive. That's the expression for that. So P is the premium, and it's paid this way. And that pays 55,000 times 10 E55 times pays 4 A:65. This is the actual present value at the policy inception at the beginning of payment of 55,000 that is paid if 55 lives, and only 55. But we haven't accounted it for that exactly because this pays also if both are alive, and you'll see in just a moment that we'll account for that. So anyway, plus the same way for this for the person who is now 65 will survive 10 years of payment of 55,000. So both of these are paid if both of them are alive, and that's a total of 110,000. But we are told that the payment is 100,000 if they both are alive. So we subtract 10,000 times the present value factor, which is accomplished by 10E55 times 10E55, which is two probabilities multiplied, which is the probability that they're both alive because they're independent, times two factors of 10, 1.05 to the negative 10. But we need only one factor to discount like that. So that's why I have 1.05 to the 10th in front. Why do I use pure endowments instead of writing it out straight? Oh, because the endowments are given in the table that I will use. So I'm trying to create a situation where I can use the table. And that's multiplied by A:65:75. Okay. So P is equal to the ratio of the right-hand side to the A double dot divided by A:55:65 angle 10. And now we have to find all these numbers from the table. So 55,000 times 10 E55 times A:65 from the table, that's equal to 55,000 times 0.59342 times 13.5498, and we calculate that to be about 442,239.73. Then 55,000 times 10 E65 times A:75 from the table, that's 55,000 times 0.55305 times 10.3178, and that's approximately 313,844.26. But please make sure, by the way, that you look at SULT table, or SALT table, whatever we choose to call it, and look up these values, because you need that experience. You'll be doing this on the test, so practice with that table. And now, the part about the joint life annuity, A.65:75. That's also in the table. Look it up, where you have the joint life tables. So we're looking at 10,000 times 1.05 to the 10th times 10e55 times 10e65 times A.65:75. So that's 10,000 times 1.05 to the 10th times 0.59342 times 0.55305 times 9.4898. And this comes out to be about 50,731.374. And also from the table A.55:65 10 is about, actually it's exactly given the table as 7.7596. Now we take all of these numbers that we just calculated together, plug it in into the formula for P, and it's approximately equal that, because all of these numbers that we get here are approximations, although I'm trying to be as precise as I can with those approximations. But nevertheless, we do this calculation, and this comes out to be about 90,900.641, which is answer D. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.